Okay, so for these probability review questions about sample spaces and events, here's my sketching out of the solutions. For this first one, with the kind of crazy librarian boss, we might think of one specific outcome. So literally just think of picking one out, one returned book, and let's say it is Huckleberry Finn. Okay, so clearly that title does not begin with a Q. That begins with an H, and so you would maybe use notation like this of using where Q stands for the event, or the outcome I should say, that is a title beginning with Q. Well, we can put a complement up there, and that says not Q. Another way you often see complements denoted that's equivalent is just to use a prime. Either way, this is going to be not Q. We don't really care what letter it is. We just want to know if it's Q or not, because then you're done. Okay? So one specific event could be a collection of these outcomes. So maybe one specific event would be not Q, not Q, not Q. Then on your fourth one, you get a Q. Okay? And what's the sample space? Well, this one may have been a little hard because it's really different than the sample spaces that I included on the video, which are arguably easier than this one. Let's start at the beginning, where maybe on that first draw of a book, you get a book that starts with the letter Q. Okay, then you're done. You have a very short work day. Or you may have the first book not be Q, and then you get a Q. First two could not be Q, and then you get a Q. Are you seeing a pattern here? Because you stop or take a break once you get something with the letter Q. So we'll have not, Q. And where the number of not can vary, that's the random element of this probability experiment. So I'll just denote that as ... because we can't be exhaustive and write out every single event that's possible here. All right, so this next one. A skydiver jumps out of a plane. He lands somewhere at random within a circle with a radius of 1 mile. So one specific outcome is he could just say land at this point. By the way, might be helpful here to draw a little picture. Okay, so 0.5, 0.25, about there. So that would be him landing about there. I'm a little off, but let's pretend it's 0.5, 0.25. So one specific event could be something a little bit more complicated, where maybe we take up an area. So it could be the set of all coordinates x, y, such that, let me just pick some values. X is between 0.5 and 0.2 and say 0.5. And y would be between 0.3 and 0.4. Okay, so there we've taken up an area, so between, I'm really going to eye it here, but 0.2 and 0.5 here. Okay, and then between 0.3, which would be about here, and 0.4, so it'd be that area. Okay, and then the sample space, I got to get this in real quick. I'm running out of time on my video. X squared, y squared, less than or equal to 1, because we know the radius is 1. And that is that script S sample space. Okay, so I wasn't quite able to finish the whole sample space and events handout, so we'll finish it up in a second video. This game requires 2 players here. The idea is they each have a die and they each roll them separately at the outset. So let's assume that for the moment, that each player rolls a die, and maybe that die determines what they can do at that particular point of the game. So if you get, for example, the first player gets a 1, and the second player gets a 2, that's different than the first player getting a 2 and the second player getting a 1, because maybe they have different instructions based upon what kind of event that they get. By the way, I'm also assuming a 6-sided die here just because it's the most familiar setting. So one specific outcome, well, I've already written one up there, a 1 and a 2. Okay, notice how I write it. It looks like 12, but it's actually denoting a outcome that's possible for each rolling the die. Okay, then we've got one specific event. So an event here could be several possible outcomes. Okay, so we could have 1 and 2. And then in another roll, maybe they get 1 and 3. Okay. Finally, for the sample space, we need to think about all the possible ways this could happen. So we've got, it might be easiest to iterate through a set where the lead stays constant. So we've got 1, 1, 1, 2, dot, 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 on up to 1, 6. Then 2, 1, which is distinct from 1, 2, recall. 2, 2, dot, 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 on up to 2, 6. I like to always think about the size of my set too. I'm going to sketch out the last few because I don't want to write these all out because there's actually 36. And the reason I know that there's 36 here is think about this. On every possible roll of the die, you have 6 possible results. Well, we're rolling a die 2 times, so there's 36. Okay? Okay, so for the second one, the difference now is one player just rolls both die. So now we're not going to assume that 1, 2 is different than 2, 1, because maybe you're just summing up the die, and so if you get 1, 2 versus 2, 1, you still just have the sum of those for determining what you do in the game, which would be 3, is the idea. Okay, so here, I'll make a little note here that 1, 2 does equal 2, 1 for our event or outcome. So one specific outcome again is, again, 1, 2. Then we could have another specific event, which would be 1, 2, 2, 4. Okay? Then the sample space, so we need to be a little bit careful here. We can start out the same way, 1, 2, on up to 1, 6. Okay? Then we can't include now 2, 1 though. Okay, so we've got to start now with 2, 2, on up to 2, 6, then 3, 3, because we can't include 3, 1, because that's already in there, and we can't include 3, 2. Okay, so we can keep going in this fashion until we get up to the last element, which would be, of course, 6, 6. So a little bit harder to think about the size of this set. But really, we're thinking about all possible combinations of the integers 1 up to 6, which is given by here, 6 choose 2. But that's not it, because we actually have to add in all those doubles. So 1, 1, 2, 2, 3, 3, and so on. So notice this ends up being 21, which is the same as actually 6 plus 5 plus 4 plus 3 plus 2. Oh, I can't fit it in 1, but you know what I mean. Check that out. That's a nice little counting identity to remember.